Hey everyone! So today I'm going to be telling you about energy and efficiency. This is still on the work, energy and power playlist. I believe is the last lesson. It is the last lesson on that playlist. So you're going to see, a playlist now built up just with these topics, okay? So what do we know already from this topic? We know that work done, which is W, comes in J joules equals the force in newtons times the displacement in meters in the direction of the force. And we know as well that if I have a machine, the output power, P out, which comes in W watts, equals to the force in newtons times the velocity in meters per second, okay? So I can now use what I know to calculate efficiency, okay? So I can get to know how efficient a machine is or whatever I'm doing is, okay? Now, remember that the principle of conservation of energy tells me that energy is never created or destroyed. It is simply converted from one form to another. So that means that my total energy is going to be or actually, let me say it in a different way. So that means that the total energy that I put in to a system comes out. It's just that it comes in different forms. So my total energy will be my useful energy, which is the energy that is transferred in the purpose that I want, so in the way that I want for the machine, plus the wasted energy, which is energy that is transferred anyway, but it doesn't go to the form that I want. So is unsuccessfully transferred for the purpose of the machine. So normally this wasted energy is something like sound and heat. So all my energy input is equal to my energy output because the principle of conservation of energy is obeyed. It's just that my total energy, my full energy output, for example, part of it is useful and part of it is wasteful, okay? So let's see an example. I have a 500 watt electric kettle, winch, that raises a weight of 150 newtons by 60 meters in 10 seconds. So the energy that I supply is these 500 watts in 10 seconds because energy is power times time. So I supplied an amount of 5,000 joules of total energy. So that's my input energy. And then all of this was used to raise a weight of 150 meters by 6 meters. So this is what I wanted to do. So my useful energy is the gravitational potential energy that I gain. So it's the force times the height, therefore is 150 newtons times 6, which is 900 joules. As you can see, my total energy supplied is larger than my useful energy. So that means that some of the energy was converted into a non-useful form. So some of the energy was wasted. So my wasted energy is my total energy that I put in the beginning, so my input energy, minus the useful energy. So that's going to be 4,000 minus 900. So that means that I get 4,100 joules of wasted energy, okay? So I can use this to calculate efficiency. And here are 3 ways that you can calculate efficiency. Efficiency is the useful energy transferred over the total energy supplied. So you can use useful energy over total input of energy. Efficiency is the work done by the machine because that's, what I want. So the work done by the machine is going to be when I get the energy being transferred usefully divided by the total energy supplied. Or then I can say that efficiency equals to my output power divided by my input power. I can use any of these 3 formulas. It just depends on what the question is giving me or what the information I have in advance, okay? Now, efficiency is a number between 0 and 1. So if you do a calculation and you get an efficiency that is larger than 1, then it means that something is wrong, okay? So you need to go over and look at your answers or your calculations. Now, efficiency does not have units because you have joules over joules, joules over joules, and watts over watts. So efficiency has no units. If you want, you can also show your answers as, instead of being with a decimal place or decimal, so a number in between 0 and 1, you can give the percentage efficiency. So the percentage efficiency is just the efficiency that you calculated times 100, and this will give you in percent, okay? And if you do that way, then your results will be right if they are in between 0 and 100%, okay? So let's look at the example that I had before. I had the total energy, I had the useful, I calculated the waste energy. So what is the efficiency? Well, out of these three formulas, I have the useful energy transferred over the total energy supplied, okay? Or I can even go on this one, work done by the machine divided by the total energy supplied. I could not use this one because although I know my input power, I don't have just there yet my output power, although I could calculate it. So what I'm going to do is the useful energy transferred, which is this, 900, and I divide it by the total energy that I supplied, which is this, which is 5,000. So I do 900 over 5,000. That gives me 0.18, no units again, remember, or then I can say that is 18%. I personally prefer to see efficiency in percentage, but it's up to you, okay? So that means that my machine is only 18% efficient. And this is what happens actually very often. The efficiency of things are quite low, generally speaking. So for example, look at this filament lamp. I give it 100 joules as input energy, and I get 12 joules of light energy. So the efficiency is only 12%. However, if I use a fluorescent lamp, which they are more efficient, I get 15 joules of supplied energy, so input energy, and I still get 12 joules of light efficiency, light energy. So my efficiency is 80%, okay? So if we want to actually use up less energy, one way is to buy things that are more efficient, okay? Because that means that for the same or a smaller amount of input energy, I get a reasonable amount or the same as before output energy or output useful energy. Other ways that you can improve efficiency: I can oil machines part to avoid energy being lost by sound. Many times energy is wasted as sound or heat. The petrol car left without insulation to avoid overheating as well, because again, energy wasted by heat. Electric motors waste less energy than petrol ones, so electric cars are more efficient. Other ways, power stations are only about 40% efficient because the turbines need to be kept cool, again, waste energy of heat energy. So the hot gases can enter the turbine to spin them, and consequently the generator to spin the generator. So again, if you want to improve the efficiency of something, you want to decrease the amount of wasted energy. Most of the times the wasted energy is sound or light, sound or heat. So you may want to see how you can avoid getting sound. Sometimes sound is caused by vibration, so fixing machine parts works sometimes, and how to decrease heat. Many times heat is caused by friction, so oiling, lubricating is a good way to do it as well. And that is it. That is it for this topic. Okay, so you're done. And yeah, so I'm going to leave the video as this. If you have any questions, again, let me know. And if you now go on YouTube, you're going to have a playlist only with work, energy, and power. Okay? So take care. Bye.